Hey guys! Welcome everyone back to our channel. Today, we will address a fascinating and impactful topic, the story of Tsar Bomba, the day we created a second sun on Earth. Before we begin, I would like to ask you to watch the video until the end, as we will explore incredible details about the hydrogen bomb and its impact on history. If you are not yet registered, don't forget to subscribe and activate the bell to receive all our updates. Share this content with your friends so everyone can learn about this historic moment. Now, let's go. In 1961, more specifically on October 30th, the world witnessed a historic milestone in the Novaya Zemlya archipelago, in northern Russia. This day would be marked as the moment when humanity created a second sun on Earth. To understand this event, it is crucial to understand the historical context and advances in the development of nuclear bombs since the Manhattan Project during World War II. The research of renowned physicists, such as Enrico Fermi and Edward Teller, gave rise to the idea of nuclear fusion bombs, in addition to the already known fission bombs. Let's explore the fundamental difference between nuclear fission and nuclear fusion. In fission, a heavy atom, such as uranium-235, splits into lighter atoms, releasing energy. On the other hand, in nuclear fusion, light atoms, such as hydrogen, combine to form heavier atoms, also releasing an impressive amount of energy. Understanding these concepts is crucial to understanding how fusion bombs, such as the Tsar Bomba, work. Physicist Edward Teller played a crucial role in the development of the nuclear fusion bomb. However, the challenge was creating the conditions necessary to initiate controlled fusion. The first stage of the design consists of a nuclear fission bomb, similar to those developed in the Manhattan Project during World War II. This stage is designed to generate enough energy, through nuclear fission, to initiate the second stage, where fusion occurs. The crucial challenge lay in achieving the conditions necessary for fusion, which involves extremely high temperatures and intense pressures. As the temperature increases, atoms lose their electrons, forming ions that repel each other due to their positive charge. Overcoming this repulsion required reaching temperatures and pressures comparable to those of the solar core. The genius of the Teller-Ulam design lies in the proposition of using a conventional nuclear bomb in the first stage. When this bomb explodes, temperatures reach an incredible 100 million degrees, providing the necessary conditions for nuclear fusion in the second stage. This efficient and ingenious method became the basis for most modern fusion bombs. Thus, the Teller-Ulam design overcame the theoretical challenges faced by Teller during the Manhattan Project, paving the way for a new era of nuclear weaponry. This technological advancement is a testament to human ingenuity, but it also warns of the dangers intrinsic to the destructive capabilities of these weapons. On November 1, 1952, Enuatak Atoll witnessed the first nuclear fusion test, codenamed Ivy Mike. The affectionately nicknamed Ivy Mike was very different from conventional nuclear bombs in terms of size and complexity. Weighing an incredible 74 tons. This fusion bomb was impractical for actual military use, mainly due to the need to keep the fusion fuel, liquid deuterium, at temperatures close to absolute zero. This requirement led to the development of cryonics technology, essential to the success of the test. When Ivy Mike was detonated, a colossal fireball 5 kilometers in diameter formed, engulfing the epicenter. The mushroom cloud reached impressive heights, reaching 41 kilometers, more than 4 times the height of Mount Everest. The explosion was so powerful that it generated 2 previously unknown elements, einsteinium and fermium. It is fascinating to note that although the Ivy Mike was a milestone in nuclear science and technology, it was not a practical weapon due to its size and logistical complexity. However, this test set the precedent for continued research into fusion bombs, with the Teller-Ulam design, used at Ivy Mike, becoming the basis for future developments in this field. The first nuclear fusion test was a monumental step, opening the door to exploring new frontiers in science and, unfortunately, the development of destructive weaponry. This episode highlights the duality of nuclear technology, capable of promoting scientific advances and, at the same time, presenting serious ethical and global security challenges. We have reached the climax of the story. On October 30, 1961, in the Novaya Zemlya archipelago, in northern Russia, the Soviet Union carried out a test that would be marked as the peak of the cap. Human destructive action. The Tsar Bomba was an extreme manifestation of Talar-Ulam's design. Its destructive potential was colossal, originally designed to release 100 megatons of energy, the equivalent of 100 million tons of TNT. This magnitude far surpassed previous nuclear bombs, such as those at Hiroshima and Nagasaki, which were on the order of kilotons. The test, however, reduced the Tsar Bomba's potential by half, releasing only 50 megatons of energy. The resulting fireball reached a diameter of 8 kilometers, covering the sky with an impressive mushroom cloud. The shock wave traveled through the Earth's atmosphere and surface 3 times, demonstrating the devastating range of this weapon. The photograph of the mushroom cloud, taken 161 kilometers away, does not do justice to its true size. The explosion generated a column that stretched 67 kilometers high, more than 7 times the height of Mount Everest. The flash of the explosion was visible 1,000 kilometers away, from Norway to Alaska. Although the Tsar Bomba was an impressive technological feat, its existence also marked a turning point. The destructive power of this colossal weapon contributed to the signing of the Partial Nuclear Test Ban Treaty, indicating a global attempt to contain the unbridled advance of nuclear weapons. Tsar Bomba stands as a grim testament to humanity's self-annihilating potential, while also highlighting the critical need to pursue peace and containment in the nuclear age. It's crucial to remember that events like this shape the nuclear age in which we still live. Even though nuclear explosions seem to belong to the past, we must remain aware of the dangers they pose. By understanding the science behind fusion bombs, we can be more informed and, perhaps, contribute to a safer world. Thank you very much for watching this far. If you liked this video and want more informative content like this, don't forget to like, share with your friends and, of course, subscribe to the channel so you don't miss any news. Your interactions are fundamental to the growth of the channel. To the next.